Hello, receiving teachers and students and class.
Hello, Mr. Kwadogi.
Thank you. You may be seated. You were given homework to do on the 3 stages of matter. One was to draw and describe solid. Second was the state of matter liquid and the state of matter gas. Let's have one for one of those 3 volunteers to describe to us and show their diagram to the class on the 3 stages of matter. First one, solid. Looks like we are still doing it. Cullen. Okay, good. Thank you. Cullen will give us the first one.
Solid takes up a defined amount of space.
Okay, thank you, Cullen, for that answer. Next one, liquid. Ruti, thank you, Ruti.
Liquids take up the defined amount of space.
Okay. Come again, Ruti. What's your answer?
Liquids take up a defined amount of space.
Thank you, Ruti, for the answer. And we'll have finally Daisy.
Gas expand to fill whatever space is available.
All right, thank you for your answer. Teachers, we are still on the same strand, same substrand, and the same outcome. Our topic for today's lesson is, how does matter behave? Particles of solid, liquid, and gases. How do the particles of these 3 states of matter, which is solid, liquid, and gas, behave? All right. There are some piece of paper which I will give to you. Please take one and pass the rest to the group. One for each group. Yeah. Get one for your group and pass the rest. All groups have a piece of paper each? No? Okay. What I would like you to do with this paper? What kind of state of matter is this piece of paper? It is a solid. Good. Now, share it between you and your friends. You can take it and share it to your friends. Share the paper, tear it and give it to each one of you. Quickly, it won't take long to share the paper, and each should have a piece of paper each. Some are still tearing nicely. By now everyone should have a piece of paper from the first large sheet that we're given. All have a piece of paper, Ton? Everyone should hold up their piece of paper. Let me see if everyone has a piece of paper. For our group there, do you have a piece of paper? All have a piece of paper? Begley, your group, do you have a piece of paper for everyone? All right. Place that piece of paper in front of you and tear. Keep tearing. Keep tearing until you tear to very tiny little pieces. Tear. Tear until you cannot tear no more. Tear the paper until you cannot tear no more. If you can tear the piece of paper, keep tearing. If you cannot tear, if you can tear more, keep tearing. Please put your torn piece of paper in one place. Do not drop it on the floor. Keep tearing. How many pieces of paper did you tear? Can you count? It's too many. What happens to the size of the paper? It gets smaller. Smaller and smaller. All right. Take the smallest piece of your paper. The smallest piece. Any small piece that you decide. Find the smallest piece. Okay, I found one smallest piece in my piece of paper. Piece in my piece of paper. It's very small, very, very tiny. Can we tear that? Okay. Put it away. Put one half and take another half. Can you tear that? If you can, yes. If you cannot, let's check. Very tiny. So I've got a tiny little piece of paper here. I will tear that again. And now it's about just sticking onto my finger, nail. Can you see that? Sticking onto my finger. I cannot tear no more. You too may have the same, do you? Do you think, what do you think? Is this tiny piece of paper made of? Of course it is solid. Yes, it is solid. It is not made, it is made from wood. Paper is made from wood. It is made of, Michaeline, it is made of? Paper is solid. It is made from wood. But there is something that makes up that paper, which was made from the wood.
Particles.
Particles. Paper has very tiny, tiny particles. Or all materials have very tiny, tiny particles. Even the shirt that you wear, even our fingernails, everything is made up of particles. So today we will look at particles, how they behave. Now, any volunteers? Five students. Can I have 5 students? 5. Shannon, good. Thank you. First stand up. Okay, 5 boys. Give me 5 boys and 5 girls. Okay, just come to the front. 1, 2, 3. Okay, 4 here. 5, Isaac. 2, 4. Oh, 5 already. Okay, 5, come. 5 girls. Moru. Maria. Glenda and Ruthie. Okay, facing the front in your groups. Okay. Girls, you stand there. No more on this side, girls. One more girl. Okay. Evelyn. Nola, sorry. One more 5, 5th group. 5 people. One more group of 5 people. Okay, boys this time. 1. Come, Joshua. Okay, Joshua here. Cooper. Cooper. Cullen. Okay, Cullen, good. 3 more. Okay. Who's this? Walter and Samuel, Emmanuel. Okay. All right, let's stand there. Which one, Dylan? Guess. This group. This group. You are very solid guys. So each of you, each of you hold that piece of paper and show it to your friends. One each. All right. We will have a look at your eyes to the front. Eyes to the front. Together. Come close. Okay, show your what group you are to the class. This group here, the first group we have, this is liquid. They are liquid. Liquid what? Michaelin said something. They are liquid particles. Each of them represent a liquid particle. This group here are solid. So each of them are solid particle, very strong people. This girls here, group of girls, are gas. Each of them represent one particle of gas. All clear? Okay. Now, someone, how do they behave? Solid particles. Anyone would like to tell us how solid particles behave? Yes, thank you. Michael.
They behave tough and strong. They behave tough and strong.
Tough and strong. How do you behave? Tough and strong. Come on. Anything else about solid particles? How they move or how they are arranged? Begley. Thank you, Begley.
Something they need to think about or do. Better.
Okay, thank you. Okay, what about the behavior? How do they behave? the particles? Okay, Samuel is going to help with Begley's answer.
They stick together.
They stick together. All right, they stick together. Evelyn, we'll have Evelyn. Last one. Solids, are you listening? After this, they give the description, you will follow.
When heated particles gain energy, this causes them to vibrate, move faster.
All right. Anyone to give us, that is solids. Anyone to give us a description of how liquids behave? Liquids, what do you think? How will you behave? Okay, Walter's still thinking. Any others? Laylan? Thank you, Laylan.
When heated, the speed of the particles increase.
Okay. Anything else? Jubilee?
They swim around freely.
Okay. Guess. Let's move to guess. Clement.
They float around freely.
Float around freely. Joshua, Edon. Joshua.
Gas particles move constantly in all directions.
Let's say they move in all directions. Lisa?
Move rapidly.
They move rapidly. Finally, we have Jenny, Angeline.
They fill whatever container they are in. They fill whatever container they are in.
Right? Fill whatever container they are in. Cullen. Cullen?
Gas particles have more energy.
More energy. All right. Gas particles have more energy. Let's go back to solid. We did not say anything much about solid. We said they are packed together. Anything else about solid? Come on. Laylan?
Strong attractive forces holding particles together.
Strong attractive force
holding particles together.
again.
Strong attractive forces holding particles together.
All right. Let's see. Solids. This is your behavior. You are packed together. You are packed together. Let's move. You are packed together. This is your behavior. You are packed together. You are strong attractive force holding particles together. So show us that. Show us that. Are they packed? Yes. All right. When they have they are strongly packed together. When heat is applied, how do they move? Can you show us solids? Come go front. Okay, okay, good. They only, I had someone say a word. Very good. They only vibrate. Do they leave themselves and go apart? No. Very good. They stay together always. Okay, good. Give them 2 claps. Right, you may sit down. Let's have liquid. There's a space. Liquids here, this space here. Now liquids have their speed increase and they swim around freely. So liquids, your description of your behavior is you increase speed. All right, may I have your attention? Class, there are 2 things we said here. They increase speed when we apply heat or when they are heated in liquids. And they swim around freely. Are liquids same as solids? Are their particles packed together? Their particles are not packed together. So they are loose or they are loosely. They have space between themselves. Enough space between themselves. Now when heat is applied, when liquid is heated, their particles what? Increase speed and they swim freely. Okay guys, now you are heated. From hot. So you are heated. Show us how you would move. How the particles of liquid would move. They're spinning and they also swim freely or move freely. Come close to this face. You might bump into your friends. Okay. All right. Did they move freely? And spin freely? Yes. All right. Thank you. Give a clap to liquid. Thank you, boys. May sit down. Lastly, gas particles. Gas particles. To the center. All right. Our description, they float around freely, move in all directions. They move rapidly, meaning they move very, very fast. They fill whatever container, or we can say whatever space they are in, and have more energy. So this means their particles are what? Close together like solids, loose like liquids, or more? Okay, good. More spread out. So show us your behavior. Come to the front. The behavior of gases. Okay. It is too far. Just close it. All right. Okay. Again, we said they have more energy when we apply heat, or when gases are heated. So when gases are heated, how do they move? I leave it to you to show to us gases. Oh, fly. Okay. All right. Thank you. They have more speed, but I think we don't have enough space, so they couldn't run. So gases move at a very small, very fast speed, and they gain a lot of energy. Thank you, girls, for your demo. Give them one clap. All right, these are your activities. There are a few pictures which you will look at, 3 pictures. You will draw how the particles are arranged in each of the diagram. Okay. Draw the particles in each of these diagrams. Your first diagram is a picture of a kettle boiling. You will draw the particles in the cloud there. What kind of state is that? What state of matter is that? In your book or on a piece in your science exercise book. Draw the particles. Draw the kettle and the steam. Draw the particles in the steam. This one here. Good, some have drawn that very good. In the cloud. One. How many you draw, but you saw the demo? How many of them? Particles. Solid particles, gas particles. You can draw small circles to indicate that they are particles. The description, think of the description and the demonstration that your friends have done, and draw that as diagram particles in. The next diagram, What state of matter is this? Next diagram. Okay. Now let's see if you have drawn something like this for your drawing. The first picture was about the particles of solid. So your picture of particles should be something like this. Now it is important for you to put some kind of strokes to show that they are vibrating. Very good. The liquid particles should have, you should have drawn something like that. These arrows indicate where they move, or direction and of particles of liquid. Finally, your gas particles should look like this. arrows showing where they're going at a high speed. So that is the behavior of particles in each of the three states of matter: solid, liquid, and gas. Our summary for today. You're a fast writer to copy down, you're a good reader to read aloud. Summary point number 1. Our next summary point. Somebody read and somebody write will help you to get that down quickly. The next summary points. Our key phrase for today, class, receiving teachers and student, is particles about what? All right, behavior of particles. Okay, that is our key phrase. Our next lesson, teachers, would be let's plan models of particles. So you will be making a model of particle. Materials that you will be required is a cardboard, 30 centimeter by 30 centimeter, the length and the width 30 by 30. Rags, a bucket of water or a container of water will do. Molding clay or clay, natural clay from the soil. Old newspapers, pair of scissors or sharp pointed object. A good one will be your biro or a pencil. You will be using that in your next lesson. With that, thank you, class. Thank you, receiving teachers and students, for your participation.